we call for a learning parameter. Learning rate is 0.01 and we take 1,000 iterations. So iteration has been going. Now see our actual prediction. See here our actual value is 1.74792. Our predicted is 1.603077. It's not similar to our actual value. I will tell you that how to make more clarity, more clear. Okay, we'll go one by one. Now let us look at its performance matrices. Now what is happened? Yeah, see our mean square error is 0.03. Our R square is 0.4. I told you that the R square more than 0.8 will be good correlation, but it is less than 0.5, so it's not be much correlated. That's why we have not get a exact prediction. So for this, see the correlation equation. So if you see any research paper, they are using machine learning model for multiple regression. They mention this correlation equation. From the correlation equation, you can do your prediction. So this is our for our training set also same. It's not good figure because of our training and testing because it's under fitting data. So that's why we are not getting a good outcome. Now we will see that what we done here. Compared to the code, this code is what is the difference is that we are doing a standardization. Standardization means whatever data we have, we are doing normalize. Normalize means the mean is 0, standard deviation is 1. If you do like that, what happens? Your data all are starting from the 0, which means nearer to 0. All features started from 0, which is normalized. Once it's normalized, you will get a better result. It is one of the trick or one of the technique when you are working machine learning problem with data set. Now you can look at same program which near what we have provided here, same, but one thing we changed is that we call the standardization, which means we normalized. Now you see how the changes here, run here, now put. Now just look at again the same package, whatever we called here, the same. Only thing is that the standard scalar we are calling import extra package from GStarsMedia. The same data we are editing here. So the same column, same data, everything is the same one. So only thing is that we are adding in this one, the scalar standardization. Let's see. Yeah, it's not. Now check it. The same data which we called. Now we did the scaling. You see, I told you that we need to split our data for training and testing. So we split that. These are the data for training purpose, and some of the data has taken, which means 80% of data for training and 20% data for testing. So here I given random state is 42. Random state 42 means that we have a data. It won't be taken order. We need to shuffle the data. From the shuffle, we have to choose the 80%. So the random state is 42 means that here it given 40, 21. So if you give random state is 1, you just see how it shuffled and data has been taken. Previously, the first data is 21. Here, the first data is 25. So there is no matter that how much value you can take. You can take your birth year also. You can take whatever value you choose 2000. So see how the shuffle is happening. See, initially 16 has came. So it doesn't matter that what is the random state. Why we are giving a random state? Today you did the simulation. After 1 week again you want to do the simulation. That you are not mentioned random state what will happen. It shuffle it to one way. So each time your result will be changed. So if you give a random state is the same one. Whatever time you are doing the simulation, all the time you get the same result. That's why we are giving the random state. So now shuffle. Again we are going to predict. You can see the prediction. Then we have to find the cost function. We have finding. We are optimizing by using gradient descent. Now we are called the learning parameter. Now look at the actual prediction. See, previously what we got when we are not calling the standardization, our actual is 1.7479, our predict is 1.6030. Now you just look at here, our actual is 1.7479, our predict is 1.5. It's almost nearer to that. Now you will check about the from where the performance matrices, how the mean square are. See, mean square is 10 to the power minus 3 level and our R square is 0.93, which means our actual and prediction has a good correlation. Okay, so like that way, if you are writing in a scratch code, suppose you want to use a library which is available in the SQL, it will be more convenient. You need to bother about to optimize the grid reason at all. It has been inside all the things will be there. Just you call the package and then implement it. So just look at here. The same thing, same everyone. Only thing is that we call this model, we fit the model. Just look at same data set we have taken, we run it, yeah. So only thing is what we done is when compared to previous one, here we call a linear regression model from the SKLR model. The only thing is that we have done. So now the same data has been taken. So we trained our module. So this is our X train, which means that we split the 142, we split our data. Then we call this model linear regression. Okay. Then we fit this model. Once it's fitted, now we just look at our absolute prediction. See the training or training R square and testing R square. So see, previously we got here 1.71 by using our own method for gradient descent and cost function. Here we have not elsewhere mentioned what is our gradient descent, what is our cost function. By just calling this package itself already pre-programmed with it, it will call that and it will do the operation and everything. Just we need to call that package, what is which package is relevant for our company. It did all that. It did all the things. C is 1.7478, we predicted is 1.775. Here 1.52, here 1.51. Now just look at for training R square is 0.99 and its mean square is very less. Our testing R square is 0.99. Our result, our mean square is 0.0031. From this, what we can understand that our result is not overfitting, our result is not underfitting, it is a good fit. If it is overfitting, our training will be good, testing means R square will be low. But here all we are one, so our training and testing has been a good, so it's not overfitting, it's not underfitting, it's a good fit. So now we can see the coefficients. So this is our coefficient equation. I just tell you that why we did this analysis. So what is the use of this? See, I'm working in fluid dynamics model. I'm working in numerical techniques. So each field have different Prandtl number. So I took Prandtl number is 0.72, which means that it is a Prandtl number. Okay. During a computation, if you take Prandtl number is high, maybe 1000 or 2000 or 3000, computation won't go because some certain level only the computation will happen. But I want to predict what is, suppose in Prandtl number is 10,000, Prandtl number is 1 lakh, what will be my skin correction factor? I cannot be do because of the computation has been written. We need to enhance our board, we need to find a new numerical scheme. It will be very difficult for our simple data prediction. So what we can do that, we can call this machine learning by training, we can predict that suppose if Prandtl number is 10,000, Prandtl number is 2,000. You just look at here, initially we given the Prandtl number is 0.7, I given the same 0.71, it's a Prandtl number. See, my prediction is 1.6074. So it will be here 1.60, 1.6, Prandtl number is 7, 1.6074, 1. Maybe some 60, 1. Somewhere is, yeah, somewhere it will be there. So what I am going to do that, if I am taking Prandtl number is 6.2. 6.2 Prandtl number is of water Prandtl number and experimental gross to 1. See, if Prandtl number from gas to fluid is going, the spin friction is going to be more negative, which means that the fluid staying over the surface is making rough the surface. Suppose if I am going kerosene, I have kerosene fluid. When fluid is a kerosene, then just look at kerosene Prandtl number is 10. Now we can look at still more negative. Okay, some future someone has been predicted the Prandtl number is 1 lakh, maybe 10,000. They find out some fluid, its Prandtl number is 10,000. Then what is the spin friction? It is minus 3005. So if you using the If you're adding as a fluid, different fluids, like a liquids, your skin friction going to be affect much more. So if you going as a air, like a 0.1 is a medium gas, now you can look at this triangle, oh, it's a positive. So the air cases is not affecting the surface, but the liquid case is going to affect the surface. So like that you can write your manuscript or you can give the results when you are working. It will be very good for the publication purpose. So, like that, we can apply that linear regression. Now we can go to the neural network. Why neural network is important? So here, one of my friends is there, his computation field dynamics guy. He is working in computation analysis. So his whole domain he mentioned to be 1 lakh degrees. But for computation purpose, he taking 3 months to do one simulation. If he did any mistake, again you need to run the code for 3 months. So what he can do that, what he did that, he took, he's in his domain, okay, where he need a fine mesh, then he enhance the clip size. Where he see that pressure or heat transfer is very less or it's really noticeable, then he reduce the cases he reduce the grid sizes. From this, he reduced to 1 lakh grids to 65,000 grids. Then he did the simulation. Within 2 months, he finished the simulation. This is a very simple example which I based in real life. So as similar that when you are working in different modules, based on your problem, you can apply the neural networks. Okay, in your academic perspective. If you're coming into real life problems, here we have cases high voltage heater systems. So what he will do that we are living in a cold country. So here sometimes go -3, -4. All the time we cannot be adjust our heater. Okay, so what is going to happen? It will see atmospheric outside temperature, it see inside temperature. Due to deep learning, the system automatically update will give the heated class. It will give like a temperature or this much temperature will be maintained. So like this kind of advanced AI technologies have been by using neural network in electronic equipments. Many places it has been applied. So that's what the neural network is very important. In recently, what happened that one of the research journal is called the Award Publishing International Journal of Numerical Metallurgy will go all for special issue for only for neural networks because that much importance has been thrown in field flow problems for neural network. So if you are applying a neural network, it should be a big domain. But I will give you a simple example. The architecture of neural network or it will contain first of all input layer, then after it contain a hidden layers, then contain output layer. So input layer information passes through another layer by the activation function. So regression and neural network both have same, but in regression you don't have any type of activation function. But if you come into the neural network, there is an activation function. This is only difference between a neural network and regression. Okay, in regression you doesn't have the activation function. If you come into the neural network, you have the activation function. Each model has a different type of activation function. It's called sigmoid activation function, rail activation function. Most famous for computation purpose, the people are using rail activation function. So it has a different equation. So each neuron, the information passes to another user by using the activation function. Okay, so like you just see here, you will take this particular node hidden layer 3. This node information comes from this neighborhood node by using activation function. It passes through output layer also as the activation function. So each layer can use different activation function also based on your complexity of the problem. Okay. So how to build the same model by using neural network? So if you are working neural network, you need to use a package called TensorFlow. TensorFlow is very famous. It was developed by Google. Still many development is going on. All mathematicians are working in the development of TensorFlow. If you are familiar with TensorFlow, you need to know about the PyTorch also. So if you both is familiar with this TensorFlow and PyTorch, it will be very good for the company job. Recently, I applied for Facebook Meta for Tensor for my job purpose because I'm working in TensorFlow right now. They are developing TensorFlows for future prediction by artificial intelligence. So if you are familiar with the TensorFlow, you may get good opportunity in future. Okay. So here also same, we need to call for a TensorFlow or TF. Then we need to train, extend, and widen the same. We are splitting like that. Then we need to make an like a neural network architecture. Neural network architecture, the input layer hidden. This is the input layer. Along with work as data layer. So I call the activation function prelude. So the same next layer of my data layer, same activation function. Then this is the output layer. So our regression problem, we use the gradient descent for optimization purpose. Here we are using an optimizer. So there are different optimizers are the stochastic optimizer. So here I am using a regular. Here I am using Adam optimizer. Okay, as per your model, as per your memory, you can take one optimizer is important. Then we have fit the our model. After fitting that, we find the evaluation for performance matrices by using U square and R square. Then you can get the result. See your program, how it is working. This is also very simple feed forward neural network. Okay, you can apply convolutional neural network. You can apply a recurrent neural network. Suppose you are going to predict financial problems. Very famous scheme, very famous is recurrent neural network. The people are applying to financial prediction by using recurrent neural network. If you are going to image processing, you can apply convolutional neural network or GRN, graphical recurrent neural network. So based on your problem, you can choose the different neural networks. All the neural networks or all the regressions, basic concept is same, direction of cross function. But the thing is that based on your problem, which model, which method you are going to use, so how it will work that you can understand is fine. So here we call the same packages all the same. Only thing is that we call this package called example. See, it will take some time because of example is a big package. We have to do manual installation. So it takes some time. It will call if you go to our website and analyze the example package has been installed or not. It will be recommended. It takes some time. So what we done is here, we call these treated our data as different 8 batches. So you can enhance your batches also. These are all hypertraining parameters, batch size, approach, learning rate, all are the hypertraining parameters. If the approach means that previously we call an iteration. Here we say as approach. Why is the name is different? Because iteration means to know that we are working in the competition. One step information, then go to next step information. But approach is not like that. We have 8 batches. So one batch is complete, we got one approach. So like one data set, it will go for 8 batches. So 8 batches have been complete, one approach. So like that, it run 800 approach, it will run at 800 times. Okay. So that's what is called an approach. So same, we call the data, same as CSV file. Now just look at, yeah, we trained our model. As similar, we are splitting training and testing. Same, I'm giving 1993, and as per your convenience, you can give 42. It's very famous because all very basic researchers they are using 42. I don't know what is the fashion in that or in that number 42. As per your convenience, you can choose it. So we can. This is our neural network architecture. I'm using a neural activation function. You can use anti activation function or sigmoid activation function as per your convenience. In this research paper, they used let's go. Yeah, in this research paper, they used the sigmoid activation function. Sigmoid activation function is usually used for logistic regression problems, like classification problems, but they are applied a sigmoid activation function. But I'm not applying activation sigmoid, I'm using Relu. It will be more efficient than that sigmoid activation function. Now we can call this Adam optimizer. Because I told you right previously in regression problem we are using gradient descent, here optimizer. So different optimizers are there, stochastic optimizer, so many optimizers are there. As per your country, you can choose the optimizer. As per your problem complexity, you can choose it. Now the iteration is going on. So here we mentioned that where boss is 0, where boss is 1. Where boss is 1 means it will give each step information. If where boss is 0, there is no information, just give the outcome. So if the iteration is going on, take some time. Yeah, it is completed. Now see our R square and mean square value. See our mean square is 0.008, our R square is 0.005, so it's not a proper fit. We will update it. See, the differences are actually 7.74, here 1.711. So what we can do that, we will update our, we'll go with the little hypertraining parameter and I will shuffle the random state in different way. So what has been given initially. Shuffle also sometimes will make a sense. So we'll clear the output. We'll run it one more time. Start. It's running, it takes some time, yeah. Step by step it's coming. Now it came to this bad system. So it will be shown the outcome. So So like this, if you are applying, if you want to enhance your architecture, you can enhance the architecture. So if you want to enhance your neural network node, also you can enhance it. So based on your architecture or based on your model which you are using, it will give the best result. So based on your complexity of the problem, based on the data which this is a numerical data, so definitely you will get some good correlation. Suppose if you are doing a large data set, 10,000 data set, 1 lakh data set, like that type of data analytics you are doing, then you can enhance your complexity of architecture, choose a best neural network model, and you will get a better outcome. Choose a best optimizer. You can use stochastic optimizer, gradient optimizer. So many optimizers are there, so you can choose the best optimizer. But people are mostly working for regression model is Adam optimizer. Suppose if you are working classification model, they are using a cross entropy model, cross entropy optimizer. So as per your problem, whether it's a classification problem, it's a recognition problem, it's an image processing problem. As per your problem, as per your approach, you can choose it which is more convenient. Yeah, we give a let us write this down. Let us here all output. We will go manually because it's not manually savings. Yeah. Again, it will take some time to run this TensorFlow package. So once it will be run, then other things will be very easy one. I'll take random studies 42, this is what I'm needing. This one. So let us wait some time. We have still 3 minutes to finish it. It's running in TensorFlow because yeah, it's run. Now we will go. So we save, oh, no need to go much on, I'll do the same one. Only thing is that I change this one architecture. 32 is shorter, I use same 64. Let us check now. When we purchase, it's running now, the direction is going on. It will go 100 iterations. Once the coach has been completed, we will see our performance matrices. I think it's done. Let us check these performance matrices. What is our Oscar and V-square? So here the complex is endless. So as per your problem, we can yeah. Now little bit change. So 0.05 can come to Oscar is 0.7. So like that you can update your results. So previously our prediction is something different. Now it's come closer to this. So that's why we got a different outcome. Now we look at it like how the overfitting and underfitting is there by using by plotting training and testing graph. Is that yes, is that. So same we can calculate our future prediction based on your which parameter in future you want to check. You can give a future prediction value. You can predict. Suppose I told random is not working more than if you go 100 or 150. So based on the problem complexity. See here, our data is good fit only because our training and testing examples are very similar. You make them very nearer, but only thing is that we have to change the hypertraining parameter. The only thing is that we change will get a better result. And this is also very simple neural network, it's not much complex. If you go artificial neural network or if you go convolutional neural network, it will be more good because the problem complexity is totally different. So here the same primary number 0.72, we got this 1.7. I choose the same number, let us check. But if you go to fluid test, the prediction is changing, right? So as per your problem, you can choose what you can. Thank you. Is there any questions?
Any questions?
Audible? Yes, sir.
Thank you, Dr. Sir. It's a very wonderful presentation. Uh, Good afternoon, everyone, once again. Respected dignitaries, faculty members, and dear students. Uh, it was an eventful day with fruitful expert talks, workshops, and discussions. I would like to take an opportunity to thank each and everyone involved in this, uh, even you could say, very fruitful events. It's my privilege to propose vote of thanks on this special day. We are indeed honored today to have Dr. Varun Kumar, Professor and Associate Dean, Shabli Professional University, India, and Dr. Tamil Bhasha, Department of Mechanical Science, Ulsan National Institute of Science and Technology, South Korea, as a keynote speaker. In present times, gaining our knowledge is incomplete without hands-on and you could say hands-on and experience using the technology. Dr. Varun Kumar has given us the workshop based on the university data sets, how we can solve the admission related queries. Dr. Tamil Pasha has given us insightful on the future modeling and predictions modeling. How the things are going on as far as the data is going from data is being moving in one particular mesh. Uh, Using the machine learning and predictions of macro problems. On behalf of Mahe Dubai campus, I would like to thank Dr. Varun and Dr. Amit for taking out time of their busy schedules and being with us to share their valuable knowledge. On the behalf of organizing committee, I would like to convey the deep regards to hearty thanks to Dr. Sudhindra Samanna, academic president, for his valuable support throughout the event. A special thanks to our respected dean, Dr. S.K. Pandey and Deputy Chairperson, Dr. Rajiv Salan, for their constant support and guidance, which has been instrumental in this symposium. Uh, Thank you, participants, our future researchers and engineers from Mahe Dubai and international universities for your participations in this forum. I would like to thank all the program directors, coordinators of the School of Engineering 90 for their timely advice and guidance. My special thanks to Dr. Javed for technical guidance and support, department faculties. Words are not enough to thank their constant guidance and support to shape this symposium. This event, which has virtual component, would not be possible without the seamless technical support. And a great thanks to Mr. Shekhar, Ms. Anjuma, Mr. Shubhani, Mr. Khalid, Mr. Ali, and all the staff from the facility departments. Finally, a big thanks to all the students, volunteers from the School of Engineering and IT for the smooth conductions for this symposium. Thank you very much.
You want to say something to him?
I don't know who have food. Yes, you can't use this. Laptop is here. Laptop. Someone's laptop is here. It's just there. I don't know whose is it. Javed sir, किसका laptop है ये?
No, sir. ये है कॉलेज का. हाँ, चलो. So, okay, you guys stay for some time. You need to little clean up the stuff. Someone bring the mic, stand. Someone bring the stand from the other. ये दुकान मत करना. ये दुकान. Shit. Can you disconnect the wire first? Yeah. Can you remove that camera also on top? So थोड़ा नीचे डाउन कर दो. डाउन.
Sir, anything from there you have to take?
That camera stand. That one, someone take it to my office.
Wait, this one is, I don't think this is required. So, what about this?
Let us say there only. Keep it there. And that laptop charger you can keep it there only. हाँ, वो सुभान सर को देना है. वो और वो दो, you know, सुभान ही ना, उनको दे. First floor पे सुभान ही देना है.
Nothing else we need from here.
This one, leave it there, the charger. This one, take it to my office.
So, ये भी निकालना है.
वो चार्जर है. चार्जर.
सर ये आपका
काम है.
सर ये भाई
पूरा मेरा नहीं. कॉलेज प्रॉपर्टी है.